In this video, we will explore the most important recommendations and common mistakes to avoid so that your air conditioner cools more efficiently while consuming less energy. We will start with the simplest tips and progress to the more complex ones. As a first recommendation, it is essential to pay special attention to the cleanliness of the indoor unit's filter and the outdoor unit's coil. Keeping these components clean ensures proper airflow, which helps maintain optimal temperatures in both units and prevents issues such as incorrect pressures or system inefficiency. What is the ideal temperature to set your air conditioner for energy savings while maintaining comfort? It's important to understand that for every degree Celsius, about 2 degrees Fahrenheit, that you lower the thermostat, your system's energy consumption increases by roughly 8%. This translates directly into higher electricity costs. For instance, if the cooling cost for running the air conditioner at a set temperature of 20 degrees Celsius 68 degrees Fahrenheit over a month amounts to $100, increasing the thermostat setting to 23 degrees Celsius 73 degrees Fahrenheit could lower the cost to around $76. This means a potential savings of up to 24%. Ideally, the difference between the outdoor temperature and your desired indoor temperature should not exceed 12 degrees Celsius 24 degrees Fahrenheit to balance comfort and energy efficiency. Recommendations for placing the indoor unit. In small rooms, mount the unit on the widest wall for even airflow distribution. In medium-sized rooms, with one wall being twice as long as the other, install the unit on the shorter wall. In larger spaces, it's better to use 2 units to ensure uniform cooling. Always position the indoor unit away from doors, windows, heat sources, and areas with excessive dust. Install the indoor unit as high as possible, while maintaining the manufacturer recommended distance from the ceiling. Common mistakes in outdoor unit placement. Outdoor units, condensers, require proper ventilation. Placing them in cramped spaces can severely limit airflow and reduce efficiency. Solutions include placing the condenser in the coolest location available, shaded from direct sunlight. Avoiding obstruction of the air discharge areas, and keeping a safe distance from walls. Ensuring the airflow direction of the condenser is not opposing strong external winds. Proper insulation for air conditioner pipes. Each pipe should have its own independent insulation to prevent heat exchange between them. Reducing the length of the thicker suction pipe, which carries refrigerant from the indoor unit to the compressor, minimizes thermal exchange with the surrounding environment. This helps to lower the refrigerant's total superheat, reducing compressor workload and energy consumption. Even with insulated pipes, shortening their length can reduce the heat transfer area. This is particularly crucial for maintaining a cooler refrigerant temperature, especially for systems using R32 refrigerant in hot climates. Reducing the unnecessary length of refrigerant pipes improves energy efficiency by decreasing the distance the refrigerant must travel. This lowers the mass flow rate required to maintain normal operating pressures in the indoor unit. It also decreases pressure drops in the thinner capillary tube, reducing flash vapor formation and increasing the liquid refrigerant delivered to the indoor coil, thus improving performance. Any vapor arriving at the indoor coil represents a portion of refrigerant that cannot efficiently absorb heat. Minimizing this improves the cooling effect and energy efficiency. Furthermore, shortening the thinner liquid line reduces the risk of heat gain from the environment, maximizing the amount of liquid refrigerant reaching the indoor unit.